Hello all, welcome back to CAD Technologies. Today in this video we'll be seeing how to make a simple curved spanner as you can see on the screen. The curved spanner actually has few views given here with a detailed view. First, let me try to explain the drawing and then we'll proceed and make the component. Now, understanding the drawing is the main concept of making any 3D model. Here we can understand that there are two views. I can see that the major design of the view is shown over here, whereas few feature definitions are shown in this view. So since that is the way the views are represented, I will consider this as the front view and this as the right view. Now, assuming this as the front view, let us understand the next part is that there is a varying cross section throughout the spanner. That is this 30, 35 and 40, but the depth is always 10. There is no change in the depth. There is variation in the addition of material or the depth for these features, which you can see in the right view. Apart from this, they have also shown us a detail view, which is named A, onto the other side for better understanding of the internal cuts. Now, the 110 TYP is same for this as well as for this side, so that's why they have mentioned 110 and then mentioned typical. So we can understand it that way. Another typical mentioned here is 114 typical radii, which is this arc is 114 as well as this arc is 114. Now, there is also one more which is R40. R40 is actually for a radii, the radii of the corner, which we will see how to make the R40 using our fillet command. This can be made simply by using your part modeling, but since there are varying cross sections, we will be using a multi-section solid. Now, let us begin by making the component under a part design. First, for multi-section solid, we know that we need to make the path first. So, assuming this is my front view, let me try to make this path first and then proceed with the profiles. Again, I am trying to make a sketch. There are 2 points. There is one over here and then I am trying to create a mirror image. These two are my references. I will keep them in a construction mode. The overall distance for these is 275, which is maintained symmetrically. I'll take it 275 from here to here and maintain symmetrically. Let me fit it to the screen so you can see. Now, from here there are few sketches. Let's begin making one after the other. There is a straight line this way. The angle from here to here is actually 20, which they have already given. And even that is TYP, that means the bottom side also is of 20, as in this angle is also 20. And the depth of this is 32. From here there is an arc which is going this way. Let me not intersect it anywhere. Let me try to maintain tangency and then give the dimension, which is 114. It takes the shape automatically. Same way there is another line here which is actually maintaining parallelism with this. So I can maintain parallelism also, or I can give the dimensions. There is no issue with that. And then there is an arc. The height of this is 40. So let me try to take this as 40. You can follow the step-by-step procedure or you can understand the drawing and do the same thing as well. Go still here. Let me try to maintain tangency here and then try to maintain tangency here. Now the radii of this arc will be auto-constrained with respect to this. So let me try to delete since they are overly constrained. Now the variation of the paths are at the beginning, the center as well as at the end. Now, the variation will be in the software, it will be at this location and this location at this location. So, we require 3 different planes to maintain the profile. So, let me try to take a plane perpendicular to this curve first and try to make a sketch on this particular plane. Now, understanding this, the view is actually supposed to be this way. So, let me get back to the normal view and then try to make the profile. And let us check once the profile is done if it's in the right way or not by taking other views as well. So this is supposed to be 30 and this is supposed to be 10. Now this drawing as per the front view is supposed to be the other way around. Yes. So the front view is supposed to be the other way around. That means this is supposed to be 10 and this is supposed to be 30. The profile got a little rotated. So when I go back to my isometric view, we can check if it's correct or not. Now it is exactly correct. Now once I exit, we can see the profile. The same profile will be located at this point, as we can see. On this, let me try to make the profile. The profile is the same, but there will be a variation in the dimensions. Let me try to project the point, zoom in a little bit. Okay. The change in dimensions are actually 35. Again, zoom out a little bit to see. Yes. This is supposed to be 10, which is as per the drawing, and this is supposed to be 35. Again, as per the drawing, as you can see, this is 35. Now, towards the end, the profile is actually 40 by 10. So, towards the end, let us take a plane and then maintain the same as per our sketch. So, again, I am taking a sketch. I am trying to project this, which we have done a little while back. Follow the same process. Take a rectangle. Make sure they are matching with the views in the drawing and then proceed with the model. This is 10 and this is supposed to be 40. Now, the material of addition should happen in between these three profiles. They are non uniform. That means they have a varying section. So we can use multi-section solids to do so. This is my first, considering this as my closing point. This will be my second, considering the same. I think it has, okay, it has taken another closing point. Let us try to replace that. Now, considering the third, this will be my third sketch. So let me try to add that as well. And closing point is given. Now, instead of directly computing the spine, I am giving the software the path it is supposed to follow. So once I say preview, it creates the perfect shape, as you can see. Here we have three profiles. I am not getting into coupling now. To achieve these shapes, first let us try to remove a certain amount of material, or you can add material inside a material also. But in this software, it usually tends to merge the bodies, but all softwares do not do that. So, assuming the earlier sketch, let me try to unhide the earlier sketch. This is the reference which I will be using, and I will be making the circle over here. And the diameter of this circle, or the radii of this circle, is given as 27. So, I am just taking this as 27. I'll just remove this material instead of, I'm sorry, I took pad. I'll remove that particular portion of material instead of taking the whole shape and then redoing the whole process. It's a little time taking process. So I'll just try to take this and give the radii 27 and then try to remove the material. It tries to cut the material up to the next surface. Later on, I can again add the material as per the shape. Following the feature based modeling, I am trying to make the model following the feature based modeling. Now the circle at the below located over here is 32 radii, so I will take this as 32. And I hope I am in pocket command. Yes, I am in pocket command. It cuts up to the next. Now, let us try to add the material. I can use the center plane because we have given both the sides. I mean, as in symmetry addition of material. We can see that in the right view or in the top view, anywhere you like. So now I'd like to use the center plane. So there are different addition of materials provided to me. So considering this as a center plane, let us try to add material and do it with respect to the exact shape provided to us. Again, I'm taking my references and then I'm taking my profiles. Now, while doing so, there is a shape this way, as you can see. So let's try to make that. I have a shape this way. And this has to be in parallelism with this. I can mirror this onto the other side. It's an easier option, so I'm using that. Now we know that the overall length of this is 23 and the distance between both of them which is maintained is 24. Also there is a small arc V cut type of a shape which is follows, and then we can maintain the 110 typical. Let me try to give the constants which are missing. Coincide, does the job. Now whatever is not required, we can just directly trim it using a trim command, as you can see, and then start adding the material by using the pad. There is an open sketch somewhere over here. Okay, it is not joined. Okay, try to trim the small portion. Yes. Now addition of material actually is done on both the sides equally to 16. So I can just give 8. So it mirrored even doubles the value and it does it onto the other side. Repeat the same process for the other side of your spanner as well over here. Again, I'm trying to use my references, earlier references, whatever I have, and then I'm trying to make the profile. Following the same process, I have a straight line this way. Again, I'm trying to maintain parallelism and do this. I can mirror them both in one attempt onto the other side. Now we know again we know the distances as well as the lengths. So we know this, which is actually 25, and we also know the distance between these two is 34. We know that 110 is again supposed to be maintained, so let us try to maintain the 110 as well. Trim whatever is not needed. Exit, and of course it's not a self-instructing sketch now. Since it's 19, I'll be giving 19 by 2, which is 9.5 on both the sides. This will be your addition of material. Now we can give rounds R40 using our fillet. Just let me try to rotate the model and select the edges first. Since they are the same throughout, I am just giving them in one round. That is 40. I don't think it can accept 40. Let's try to give 30. Yes. It's not taking 40 because the profile is trying to break. This is your 30. This is how you make a curved spanner using CATIA as the CAD tool. You can do the same thing using surfacing as well. You can merge the bodies and also give it a try. If you want to learn more about part modeling, surfacing and advanced level of CATIA, please feel free to contact us. Our details are given in the description below. If meanwhile, please like and subscribe to our channel so we can keep posting more tutorials like this for easy practices as well as few complicated practice sessions. Thank you.